Hey everybody, this is Mr. Hodges, and this is the first of a series of video PowerPoints on laboratory methods. We will be putting several of these out this year to go over key points and key laboratory techniques that you need to be aware of. As a reminder, you are expected to take Cornell notes during this video. If you haven't already watched our video on Cornell notes, I suggest you stop and come back when you finish that one. So welcome back. Isn't Miss Inlin pretty awesome? Okay, so in this set of notes, it's important to listen to the presentation as well as read what is on the screen. There's a magic button called pause that I encourage you to use if I am talking too fast or you feel as though what is on the screen is very important. Then pause the video and get that into your notes in the correct format. Just be careful, because sometimes I will say something that isn't in the notes, but you will want to write that down. This is an important skill to develop as you progress through high school and have already mastered it by the time you've entered college. If this is the first time going through the material, try to focus in on key terms, facts, and examples. When you go back to review your notes over time, you will add your own questions, you will add highlighting and summaries. So this video, we will answer how do you create a data table, what is the difference between independent and dependent variables, and what is water displacement. Okay. Data tables. It is an expectation for all pre-ACE, ACE, and college science classes that students can create an appropriate data table for experiments in labs. Each experiment is different, and you will need to read through the procedure and determine the independent and dependent variables of the experiment in order to create an appropriate and unique data table. Notice that I listed the independent variables here with the tagline with units, meaning you need to be aware of the measurement unit that you are using for these variables. The independent variable is the variable that you have control over. It is what you can choose and manipulate. It is usually what you think will affect the dependent variable. In some cases, you may not be able to manipulate the independent variable. It may be something that is already there and is fixed, something you would like to evaluate with respect to how it affects something else. A dependent variable is what you measure in the experiment and what is affected during the experiment. The dependent variable responds to the independent variable. It is called dependent because it depends on the independent variable. In a scientific experiment, you cannot have a dependent variable without an independent variable. Let's look at an example. Jasmine wants to know how adding a solution of lead nitrate will affect the number of green bean pods a plant can grow. She will use 10 milliliters, 15 milliliters, and 30 milliliters of lead nitrate. In this case, Jasmine will be controlling the amount of lead nitrate. As such, it is considered the independent variable or the cause behind the plant's reaction. Jasmine will measure the plant's growth. Because Jasmine doesn't know in advance the exact growth and its potential effect by the amount of lead nitrate, the growth is considered the dependent variable. In this case, the count of the number of green bean pods that grow. Once you have identified the variables with their units, you want to put this together into a grid where you have them listed in a form that is appropriate. The first column is typically the independent variable with its units. Normally, there is only one independent variable, but if there's more, continue to list them next to the first one. You will then indicate the number of rows for each trial, typically where you manipulate the independent variable. The second and other columns are for your dependent variables with their units, or for calculations using the dependent variables. When creating the data table, make sure not to write out independent variable or dependent variable. Instead, you want to label it with the appropriate measurement of what it really is. For example, from our previous example, we know that the independent variable is the volume of lead nitrate. And we know that those measurements are in milliliters. And there are 3 different trials that Jasmine is going to undergo. A 10 milliliter trial, a 15 milliliter trial, and a 30 milliliter trial. In this case, the dependent variable is the number of green bean pods. And because this is a simple count, we put that in parentheses instead of in a unit like milliliters that we did for volume. Okay, so an appropriate table would look like this. Notice the units for the volume of lead is not repeated in the table. Also, the number of green bean pods is empty because we haven't done the experiment yet. Our first experiment that we are going to look at is going to be water displacement. This is a technique that is used to determine the volume of an irregular solid. Remember that volume is the amount of space an object takes up. An irregular solid is a solid that doesn't have a shape that is easily defined in mathematical terms. For example, the volume of a human is not defined by a mathematical equation, but if we had a cube, we could describe that equation as length times width times height. It could also be used as a means to double check the accuracy of length measurements for a regular solid. So although we use water displacement for irregular solids, we can use it for regular solids as a way to double check other measurements. This technique centers around a known fact. A solid will displace an amount of water equal to the solid's own volume. Now, we have a small little video here that's going to go through so that you're not directly listening to me throughout the whole thing. So during the video, again, if there's something that is said, make sure that you pause so you can get it down into your notes. And the video will start automatically eventually. All right, so let's take a look at what these instructions would look like if we had them written down. Okay, so first off, we want to carefully add a an amount of water to an appropriately sized graduated cylinder. When we say appropriately sized graduated cylinder, we are referring to a graduated cylinder that is large enough for the object to fit into. We are going to record this volume as the initial volume of water, and typically we measure this in milliliters. Slowly and carefully lower the solid into the water. Make sure not to drop the solid, for it could make the water splash from the cylinder and could potentially break the glass cylinder. Then you want to record this new volume of the water plus the object. Again, it's going to be recorded in milliliters. And then to calculate the volume of the object, we simply subtract the initial volume from the new volume. Now, in a moment, we will once again show these instructions, but when this happens, pause the video and see if you can identify the independent and dependent variables. It's not as clearly defined as our previous example, but you should be able to ferret out what is being controlled and then what part is going to be measured after the experiment. All right, so you paused this video. You went through and attempted to identify the independent and dependent variable. So let's take a look at what this is going to look like in a data table. So the data table for water displacement is going to have the initial volume of water as our independent variable. We know how much we are starting with. Then our final volume is going to be our first dependent variable, and that is going to be the volume of the water plus the object. Then you'll notice on the end of the column, we have a calculation. That is also a dependent variable because it is going to be calculated from another dependent variable. So the volume of the object is going into the last column, and that is also in milliliters. Then you would go through and perform the experiment, record the data in the appropriate columns, and perform any calculations. So this is what it looks like if a student were to go through here and the initial volume was 12, and then after they added the object, the volume raised to a total volume of 14.6. Okay, so initial volume of 12, final volume of 14.6 means what is the volume of the object? Real quick, take your calculator out if you can't do this in your head. Oh my goodness, I can't believe that you asked me to take out a calculator. You didn't warn me. Pause the video. All right, here's the answer. The volume is 2.6. So 14.6 minus 12 equals 2.6. All right, guys, don't forget that you have a short quiz to take over these notes in Blackboard. Bring any questions that you may have to class, and I hope you learned something new.